Well, good evening, everybody, or good morning to those of you in Australia. I just wanted to you've all seen the profile and summary of the talk, but I just wanted to highlight this is really an interesting talk to me. Neil is a fellow physician, but a radiologist. I'm not a radiologist, hematologist, oncologist, but still, he's been able to gather together the efforts of a lot of people and bring it together to tackle a massive problem in Australia, and he'll tell us all about it. And I think at this point, I'll hand it over to you, Neil. We're very honored to have you with us.
Well, thank you, and it's an honour to present at CACOR Live. This is an attempt at a very wide boundary dot connecting perspective of the harmful algal bloom, which has been widely described as an ongoing ecological catastrophe. Hopefully, at the end, you'll be able to discern the real significance of the moribund canary and the mountain goat from our planetary flight deck. We'll start with an acknowledgement of country. We meet on the lands of the Kaurna people, or wherever you may be located, and acknowledge that sovereignty to this land was never ceded. We acknowledge the centuries of resistance that indigenous people have led against the unsustainable and inhumane practices of colonisation. We pay our respect to elders past, present and emerging, and recognise their continuing connection to land, waters, culture, language and community. We commit to learn from Indigenous knowledge systems and wisdom that have been developed and used by the Gaia custodians for countless generations and express gratitude for their stewardship of these lands. We commit to walk together towards peace, justice and reconciliation. This algal bloom, which the public first became aware of in March 2025, has spurred a lot of community interest in various aspects of community science. This attempt at a wide boundary perspective draws heavily on the writings, presentations and insights of these four people I've listed, who you're no doubt very familiar with, and I strongly recommend them. I'll present what I think is a plausible timeline-based narrative, drawing on Indigenous, scientific and spiritual perspectives, but this is a personal account and not in any way peer-reviewed and should be treated as such. I'd also like to thank the many people who've given up their time and very, very generously helped me better understand what was going on. So the key messages of this talk are as follows. The South Australian harmful algal bloom is a story of odd, extreme and unprecedented variance beyond expectations, which needs to be seen as a marker of ecosystem tipping and treated as such. It's a true canary in the coal mine and is linked in broader ways to the following critical issues. Bottom line, immediate drastic cuts to fossil fuels are essential and the only way out. If Gaia or Mother Earth is willing at this very late stage, this will necessarily involve a transformation in the way we live. As there are a lot of slides, I'll only be summarising the important parts and takeaway messages, and they'll be uploaded for any future use you may have for them, such as referencing. Algae, the plural, is an informal grouping, while singular or multicellular aquatic organisms, the ones we'll be considering today are the photosynthetic single-cell and marine-based organisms, and from the protist group and the bacteria group. Plankton is another related informal grouping. They are the wanderers or the drifters of the waters, and they move with the currents. They're vulnerable to subtle environmental changes and therefore regarded as canaries in the coal mine and indicators of environmental stress or shifts. The subgroup of phytoplankton are mostly microscopic single-cell photosynthetic organisms and the foundation of the marine food web. They generate at least 50% of the oxygen we breathe and are part of the microalgae group. They include cyanobacteria, diatoms, and dinoflagellates, all of which can potentially cause harm, as well as coccolithophores. A bloom occurs when there is significantly faster growth and or less population loss than adjacent communities. And while there can be multiple interacting factors involved, as you shall see, the bloom species or species mix is the one best able to absorb useful energy for survival and reproduction. A harmful bloom can be harmful at different levels and in different ways. Generation of lethal hypoxia, alterations to ecosystems and food webs, and production of biotoxins are some mechanisms. This South Australian bloom is caused by a mix of Karenia genus dinoflagellates, dominated by the Karenia cristata species, which will be coming back to this. Many blooms are not overtly harmful and are the basis of marine productivity. In terms of a very quick geographical tour, South Australian coastal geography includes two large peninsulas, the Yorke and Eyre Peninsula, the capital, the Spencer Gulf and the Gulf St. Vincent, the capital city Adelaide on the eastern coast of Gulf St. Vincent at 35 degrees latitude, Kangaroo Island, the Bonny Coast down in the southeast of the state, and the eastern part of the Great Australian Bight to the west. We'll come back to this map later. The messages related to the overarching cause of this algal bloom have been made explicitly. It's climate change. Nicholas Burry, the Chief Medical Health Officer of South Australia, said, "Climate change is the biggest threat to human health. It's not in the future, it's happening now." Susan Close, the Environmental Minister, last year said, "This is not a one-off tragedy, it's a warning of what lies ahead if we don't act fast on climate. Our marine ecosystems are incredibly vulnerable, and they're telling us something loud and clear. A full-scale climate emergency is in the coastal waters. We can't hide our head in the sand." So let's review anthropogenic climate change and what's been going on. Firstly, the Earth energy imbalance. It's increasing due to greenhouse gas emissions. Climate models are significantly underestimating this rise, and the reasons are incompletely understood. Anthropogenic greenhouse gas emissions have been increasing mainly through the combustion of fossil fuels and also land use changes. I won't go through this historical chart, but the summary is that the atmospheric influence on planetary temperature has been known for about 200 years. And Eunice Foote and then John Tyndall worked out the role of the greenhouse gases in the 1850s. The rest is history, so to speak. Here's the steady rise in atmospheric CO2, currently nearly 430 parts per million from a pre-industrial level of 280, the result of humanity's unabated discharge of the Earth space battery. The result, along with land use change, is an extra 700 gigatons of carbon since 1850, and 30% of this is taken up by the ocean, and up to 40% is in the important Southern Ocean. The Earth energy imbalance is the most fundamental global climate indicator that we can use to monitor what's happening and what's needed, because it all gets back to energy. The Earth energy budget is shown on the left. Energy must be conserved, it can only be transformed, losing quality in the process. The high-quality solar radiation enters the planet. There's a spectrum here on the left of the graph on the right, including shortwave infrared. Some is reflected by clouds and atmosphere and the Earth's surface. Some is also absorbed at the atmosphere by water vapor and Earth's surface and re-emitted as low-quality long-wave infrared shown on the spectrum on the right. So that's the fate of the incoming solar radiation. The long-wave infrared's fate is shown on the right of the diagram on the left. Note the role of greenhouse gases in the downwelling of radiation, ensuring a planetary surface air temperature of about 15 degrees Celsius, but rising due to the increasing anthropogenic greenhouse gas emissions. The subtraction of the energy flows out from the energy flows in at the top of atmosphere is the Earth energy imbalance, and this has been increasing, meaning energy is being increasingly trapped. Here's the spectrum diagram again on the left. 75% of the greenhouse effect is done by condensable water vapor as shown on the right, but this is a feedback greenhouse gas driven by the non-condensable greenhouse gases, of which carbon dioxide is the most important. Note that water vapor is a greenhouse gas that absorbs the incoming solar radiation, while the non-condensables absorb and scatter the long-wave infrared. Here's the highly concerning thing. The Earth energy imbalance, energy in minus energy out, is growing substantially faster than climate models predict. It's unclear why, but it looks like perhaps some positive feedback loops involving solar radiation might be involved, with albedo clouds and water vapor in the mix. The trapping is about 1.3 watts per square metre as of November 25, which equates to a huge amount of energy, currently about 14 zettajoules per year. That's about that's 14 to the 10 to the 21st, power of 10 to the 21st. As a comparison, The total global human enterprise consumes 0.6 exajoules each year. Very importantly, 90% of that trapped energy, which is about 400 exajoules over the past 50 years, goes into the oceans, and the Southern Ocean does the heavy lifting, absorbing fully 90% of that. The result of this increasing imbalance are thermodynamic, with rising global air and sea surface temperatures. Surface air and ocean temperature continue to rise. I noted yesterday's global sea surface temperature was almost at a record high. And there are major implications relating to how the planet is handling the redistribution of all this extra trapped energy from tropics to poles via wind and ocean currents. Here are some diagrams of this energy equilibration, noting an excess of short wave over long wave infrared at the tropics and a deficit at the poles. This means that the atmosphere and oceans transfer the surplus to the poles. However, the atmospheric circulation cells from equator to pole is divided into three in each hemisphere by the Coriolis force, namely the Hadley, Ferrel, and polar cells. The winds and currents are also deflected by the Coriolis force, to the right in the northern hemisphere and to the left in the southern hemisphere. Note the position of the Southern Ocean westerly winds in the Ferrel cell. We'll be coming back to these. Here's a cross-section to the three circulating atmospheric cells from tropics on the right to the South Pole on the left. Note the Hadley cell, the subtropical ridge of high pressure from dry descending air, the subtropical and polar jets high up, the westerly winds, which are actually being deflected towards you on this slide, and something extremely important called the Southern Annular Mode, or SAM. We'll be talking a lot about SAM. This is the sea level pressure difference between 40 degrees and 65 degrees latitude. So what's the impact of this rising Earth energy imbalance as a result of anthropogenic climate change? The surface winds and surface ocean currents they drive are strengthening generally. In the southern hemisphere, where we'll be focusing, there is polewards expansion of the Hadley cell and tropics, subtropical ridge intensification, polewards movement of the subtropical and polar jets. Polewards expansion of the Hadley cell means a drying trend for regions that tend to have Mediterranean-type climates. This paper suggests climate models have underestimated substantially future rainfall declines. At the same time, at the other end of the Hadley cell, the tropics are expanding into Australia's interior, and there's currently an extreme rain and flood event underway, which is notable for its long duration and extreme tropically fed moisture. The subtropical ridge intensification is important, and the number of high-pressure systems is increasing over the years, which is correlated with global temperatures. There is also anomalous high barometric pressure. The jet streams are also changing dramatically. They are the high-speed, narrow air currents that form at the top of the Hadley and Ferrel cells. The subtropical jet is not present over Australia in summer. Recently found is a dramatic poleward shift of the jet by approximately 10 degrees, comparing 1965 to 2015 data with the last 10 years, and this causes rain-producing systems to track south of the Australian continent. This results in a progressive drying and heating trend. On the left is shown the severe drought conditions impacting South Australia over the past 2 years. Adelaide's cumulative rainfall deficit has continued to increase, with totals now down 30%. Cool season rainfall is reducing, and maximum temperatures are increasing. Here are the places impacted by these changes in the Mediterranean belts. In the southern hemisphere, it's southern Australia, southwestern tip of Africa, and Chile. We may be aware of the Cape Town Day Zero event of May 2018 that was ultimately averted. Reservoir levels there fell to 21%. Another really important trend in the southern hemisphere is the trend to a positive southern annular mode, or SAM, as we discussed. As I mentioned, the SAM is a difference in the zonal mean sea level pressure at 40 degrees south and 65 degrees south. Changes in air pressure distribution cause changes in the strength and position of the westerly winds over the Southern Ocean. A positively trending SAM means an increase in the strength of the Southern Hemisphere westerly winds, which also move polewards. The graph on the left shows a trend towards this positivity from 1979 to the current year, with red areas increasingly greater than blue. This can also be shown cumulatively on the right upper graph. Concerningly, SAM has paleo or ancient climate linkages. It appears it may be a proximate mediator mechanism of climate transition, as the impact of strengthening Southern Ocean westerly winds can be very significant and related to the impact on ocean upwelling, as well as carbon dioxide absorption or release from the ocean. When it's positive, it tends to be associated with warmer paleoclimates. It's worth taking a look at the YouTube created by a university student and the link listed at the bottom of the slide for an introduction to this really important topic. The SAM is the most positive now it has been for the last 1,000 years, and this is linked to greenhouse gas emissions. The strengthening of the westerly winds is linked to the positive SAM trend, as I've discussed, and is reliably reproduced across climate models. It's also possible to directly measure them at just a few sites in the Southern Ocean. This Macquarie Island weather station confirms recent increase of the westerly average wind speed. The column graph on the bottom right showing a clear overall increase in average wind speeds across all months, comparing the 91 to 2020 data with the average across the entire data set from 1948 to 2025. So clearly these southern hemispheric changes driven by an increasing Earth energy imbalance have huge implications for what we are now experiencing in real time. So getting back to the algal bloom, besides climate change, what else was said? The public was told in 2025 by the government that there were 3 plausible contributors: the ongoing marine heat wave impacting southern Australia, the 2022-2023 River Murray flood washing extra nutrients into the sea, and an unprecedented cold water upwelling that occurred in the summer of 2023-24, which brought nutrient-rich water to the surface. Gustav Hellegraf, a globally recognized algal bloom expert, identified an upwelling event as a likely initiator and driver. We'll now look at this critically important phenomenon in more detail. What is upwelling? It's an oceanic process whereby deep, cold water is brought to the surface. It occurs in the open ocean and also in coastal areas. It's caused by various mechanisms linked to surface winds, ocean currents, and underwater topography known as being upwelling favourable. The water is typically nutrient-rich, which drives marine food web productivity and sustains biodiversity. It represents a large source of chemical and kinetic energy. There are 3 main upwelling mechanisms, can be divided into wind-driven and ocean-driven, ocean current-driven. Firstly, sustained winds in a consistent direction of the ocean surface move the top layer horizontally, so-called Ekman flow. In the southern hemisphere, the seawater layer moves to the left of the wind direction due to this Coriolis effect, which I mentioned. As the top layer of water is moved, it needs to be replaced. If the coast is to the right of the wind direction in the southern hemisphere, an upwelling process draws up colder and more nutrient-rich water from the depth of the ocean to the surface. The longer the wind persists, the greater the so-called alongshore wind stress. This is complicated, but another mechanism involves wind blowing across the open ocean away in an offshore location and away from the coast. A wind stress curl is set up, resulting in associated vertical water motion this time, not horizontal, either Ekman suction or upwelling or Ekman pumping downwelling, depending on wind direction and Ekman transport. To balance out this water movement, water flow occurs at the bottom called Sverdrup transport, which can then feed into ocean currents and strengthen them. The third upwelling mechanism involves the interaction between the ocean current at the shelf and the topography of the adjacent shelf. For example, canyons and valleys beneath the sea surface can facilitate the storage of water closer to the surface for later upwelling, as well as steer and funnel the water to the surface. So where does this coastal upwelling occur? Here's a map of the major areas of coastal upwelling, which includes the Great Southern Australian Coastal Upwelling System, extending from the west coast of Tasmania to the Eyre Peninsula. At these upwelling systems, you'll find a vast marine food web and associated biodiversity related to the large nutrient loads upwelled to the ocean surface and into the photic area where they interact with light. The eastern boundary upwelling systems, or EBUS, of the world are located along western continental boundaries and are very productive. These include the Californian, Humboldt, Canary, and Benguela upwelling systems. They share a common feature, a regular, predictable coastal upwelling of nutrient-rich water driven by a longshore equatorward surface winds and the Ekman transport mechanism. The resultant productivity is seen here on satellite imagery, where chlorophyll A concentrations are color-coded, red being the greatest. We'll be reviewing these types of images soon. Off southern Australia is a northern boundary upwelling system, which I mentioned, called the Great Southern Australian Coastal Upwelling System, which shares many features of the EBUSs. EBUSs are known to be impacted by anthropogenic climate change in different ways. So, the Great Southern Australian Coastal Upwelling System contains 4 upwelling centres, shown here in red. The largest and most consistent being the so-called Bonnie upwelling of South Australia's southeast region. While the productivity is less than the overall EBUSs, it still rivals some of the least productive eastern systems. So here are the essential features of the southern system. Firstly, the along-shore upwelling favourable southeasterly winds. Secondly, the upwelling favourable cold nutrient-rich Flinders Current, which runs east to west below the shelf at a depth of about 500 metres and fed by the Sverdrup water transport associated with the offshore wind stress curl we reviewed earlier. And lastly, the interactions of the Flinders Current with the shelf edge and its valleys, headlands and canyons. There is an intermittent warm west to east flowing current as well, known as the Lewin Current, which is not upwelling favourable. Note that Long Bay, shown here on the Lacepade shelf, is quite shallow, and we'll be discussing this space soon. This important overlap between the EBUSs and the Southern Australian system was noted by John Lagier, who wrote, "At the heart of these regional upwelling systems is wind forcing along the coast. However, wind-driven coastal upwelling is not confined to eastern boundary upwelling systems and is observed in southern Australia." Local scientists have also reported this similarity. In this 2007 state government report, it was noted that shelf waters off the eastern Great Australian Bight and the Bonnie Coast have oceanographic and ecological similarities to the eastern boundary current systems off the west coast of northern and southern Africa and North and South America. The Flinders Current is analogous to the other currents in the ecosystems, and the Flinders Current and the regime of southeasterly winds that facilitate the coastal upwelling is comparable to the variable longshore winds in these 4 EBUSs. The graphs at the bottom show the seasonal variation of the upwelling favourable southeasterly winds, which can feed into a so-called upwelling index shown on the graph on the left across the calendar. The annual upwelling season is actually celebrated, particularly along the Bonnie Coast. Here's an example of the Portland Upwelling Festival. It's important to recognise that while upwelling is a physical process, it has many varied downstream consequences at all scales. It's now well recognised that EBUSs are impacted by anthropogenic climate change in different ways, and there are very serious concerns. Indeed, significant work has been going on in this area. This 2023 publication on the left lists these areas of concern, including upwelling intensification at the poleward part of the e-buses due to the three welling mechanisms we looked at, namely stronger alongshore winds, stronger offshore wind stress curl, which leads to stronger currents and greater current topography interaction at the shelf edge. Other concerns relate to upwelling of more nutrients and alterations to the characteristics of the upwelled water, greater stratification due to increasing sea surface temperatures, the issue of generation of hypoxia, that is low water oxygen levels, and dead zones, and the impact of all these factors on the ecosystems and marine life. A further major concern shown on the right-hand side of the slide is the finding that harmful algal blooms are becoming more common in the eastern upwelling systems. And this issue forms a core research project of the global Harmful Algal Bloom initiative. For example, many of us may have heard of the recent increasingly severe and extensive toxic algal blooms in the Californian current upwelling system. A particular focus of this research is the importance of bays that exist in upwelling systems. This is a really important publication by Don Lagier in 2020 and highlights the critically important functions and wider consequences of some bays that are found in these upwelling systems, particularly those in the e-buses, although the findings are generalizable beyond these systems. He notes in relation to algal blooms in bays, these bay blooms also act as an inoculum for more widespread harmful algal blooms outside of the bays, which may occur during relaxation events. Relaxation events are when basically upwelling becomes quiescent. Some important bays are noted in each e-bus. On the right, I want to highlight some of the bays in the southern Benguela system in Africa, as we'll be coming back to this, as these are the only bays in the world that have ever had a confirmed Karenia cristata algal bloom, which is the one we are now seeing in South Australia. Some extreme upwelling events are now showing up globally, and as we should see, are loud and clear warning signs of tipping points. On the right side is the extreme 2021 event in the US Pacific Northwest, which was prolonged and intense. The graph shows the anomalous cumulative alongshore wind stress for that season compared with the mean and standard deviation of the 1985 to 2022 seasons. There's been a steady increase in the hypoxia, that is low oxygen levels, in the near bottom shelf waters off the US Pacific Northwest during the upwelling season from the 1950 to 1980 period, when it was barely existent, to the 2009 to 2018 period, during which it averaged 24%. And in this extreme 2021 upwelling event, about 50% of the near bottom water was hypoxic. The hypoxia is related to decreasing oxygen levels in the upwelled water, but particularly to the increasing nutrient loads which are upwelled under the influence of climate change and retained on the shelf, which then drives phytoplankton productivity, which eventually decomposes, consuming oxygen. By the way, at the bottom of this slide is a link to an excellent short film of this issue. Meanwhile, in 2025, in the Panama upwelling system, there was a near complete upwelling failure, as shown by the red line on the cumulative wind stress graph on the left. On the other graph, the blue thermocline line marks the boundary between the warm surface waters and the cold nutrient-rich waters below for the typical seasonal pattern, along with the 95% confidence intervals. When the thermocline moves upwards close to the sea surface, it's upwelling. The green line shows the failure of the 2025 upwelling, while the red line shows the anomalously vigorous 2026 upwelling, which is underway. So we again have this highly concerning pattern of events way outside expectations. What about the Southern Australian upwelling system and climate change? There have been several very important warnings and reports over the past 20 years, mainly related to the impact of a positive SAM trend with the associated strengthening of Southern Ocean westerly winds, the increasing wind stress curl, the related strengthening of the nutrient-rich and upwelling favourable Flinders Current, and the strengthening of the alongshore upwelling favourable southeasterly winds. The wider ecosystem implications of the major changes have also been considered. For example, Kai in 2005, over 20 years ago, said that climate models predict an upward trend of the SAM. This change in the wind stress curl causes a spin up of the entire southern mid-latitude ocean circulation. The pan-Southern Ocean scale suggests a broad impact on the marine ecosystem of the entire southern mid-latitude ocean. Hobday et al. In 2009 recognized the most important current as the Flinders Current. Anthropogenic climate change increases the strength and frequency of the southeasterly winds that drive the upwelling. Increased strength of upwelling favorable southeasterly winds could cause a major shift in ecosystem structure. Increased upwelling can also have negative impacts, including changes in community structure, for example, phytoplankton. Satina Harida in 2017 et al. Suggests that a positive SAM could facilitate the supply of more nutrient-rich subantarctic mode water. A strengthening of the Flinders Current could increase primary productivity through enhanced current-driven upwelling, and topographical upwelling may lead to considerable phytoplankton growth, and noted that water cooling events indicative of upwelling could actually be found in the absence of upwelling favourable wind. Feng et al. In 2016 noted major ocean boundary current systems around Australia, including the Flinders Current, have been strengthening. These have induced extreme oceanographic conditions. They're primarily driven by large-scale wind patterns. The strengthening of the Flinders Current is driven by the increasing trend of the wind stress curl south of Australia. The poleward shift and strengthening of the westerly winds in the Southern Ocean have increased the wind stress curls. Understanding long-term trends of the ocean boundary currents is crucial to project future changes of the coastal marine systems. Hugo Bastos de Oliveira, in his PhD thesis of 2018, showed the importance of along-shore variations in topography and the role of remote forcing on the shelf circulation. He noted that more upwelling favourable winds occur when a strong and positive southern annular mode phase develops. So back to the South Australian bloom timeline. We'll now start in November 2023 with the onset of an unprecedented upwelling across the southern Australian upwelling system, both in terms of intensity and duration. This resulted in the upwelling of very large nutrient loads and was both wind and current driven, although this can't be easily quantified. Satellite imagery can show us the cold upwelled water displayed as a blue colour. Deep blue is about 11 degrees Celsius. As we start the video in November 2023, watch for a large cold water plume from the Bonnie upwelling project into Long Bay and Lesapede Shelf. This cold water is associated with nutrient load. Other smaller upwelling centres are off the southwest tip of Kangaroo Island and the tip of Eyre Peninsula. This lasted until about June 2024. I'll just show the video now. So you can see the blue plume starting up in November 2023, very extensive. It's cold water, nutrient-rich upwelling now into January 2024. Continuing into February 2024. Very large amounts of cold, nutrient-rich water into April. May. And June. This was noted in 2024 media reports Those on the water reported very strong upwelling, sustained southeasterly winds, and plankton blooms fouling boat filters. We're having a cracker upwelling this year. It's a bumper, he stated, attributing the phenomenon to sustained southeasterly winds that have been stronger and more persistent than usual. Another person noted the filters in the boat were being changed every few days due to the presence of algae from the upwelling. It's something I've never seen in 20 years of operating out here. To do that every other day is quite exceptional. It shows the load of plankton in the water. The surfers weren't very happy. There's the worst summer for surf on the mid and south coast in living memory. Howling southeasterly winds and bugger all swell for 2 months. Definitely the strongest southeasterly winds I've ever experienced, and very cold water. Charts confirmed anonymously strong winds in southern Australian Ocean Basin from December 23 to 24, and anomalously cold water across the southern Australian coastline extending out to sea. Anomalously high sea level pressures were present in calendar year of 2024 across southern Australia, consistent with a strong subtropical ridge or descending branch of the Hadley cell. We'll now observe the biological response to this cold water upwelling by reviewing some more satellite imagery. The true colour image on the left and the chlorophyll A image on the right, which basically is an indicator of photosynthesis on satellite imagery data stored on the NASA Worldview website. It's a great resource. In mid-October and November 2023, things looked quiescent. Upwelling had not yet commenced. But soon after the onset of this upwelling event in late November, concerning reports began to appear. Absent or dead and blackened pippies, a bivalve mollusk similar to a cockle, were noted at Discovery Bay in Western Victoria. Fishers blamed the cold waters. On the 8th of January 2024, a marine kill event was reported at 8 Mile Creek Beach, just east of Port Macdonald in Riddick Bay. It mainly impacted bottom dwellers. Some sick seals were reported, and some dead freshwater spiny crays and freshwater eels were also seen. The ocean water was brown and dirty a week prior, out to 200 metres. Current upwelling event was noted. Here's some photos of the mortality event. It was noted most of the species seem to be associated with rocky reef systems. They're species that don't tend to move very far and stick to one location. Some commentary around the time. Local fishers blame red algae blooms for deoxygenating the water for in-close fish. The initial investigation of the incident suggested rainfall had entered the bay through the 8 Mile Creek and caused a low salinity event in the adjacent ocean, leading to the marine kill. You can read the details of the investigation on the link at the bottom of the slide. But there was some skepticism about this conclusion, for example, as noted in the commentary at these two websites, which you can review. Personally, I wonder about a hypoxic event involving both this marine kill and the pippy issue, but perhaps there are audience opinions about this, and perhaps an associated harmful algal bloom with the 8 Mile Creek incident. As an aside, bivalves such as pippies have been found to be variably susceptible to hypoxia, including through exposure to hypoxic upwelling. A month later, there was an outbreak of abalone viral gastroenteritis, or AVG, leading to a wild abalone kill on a reef 2.4 kilometres off Port Macdonald. This is the first time this has been detected in South Australia, but was known to be present in Victoria and Tasmania. Which made me think, could this represent viral spread by particles or plankton in strong upwelling currents? Could this be analogous to the Pacific oyster mortality syndrome, which is caused by herpes-like virus and spread by particles and plankton in ocean currents, and is monitored in South Australia? AVG is also caused by a herpes-like virus, although abalone are gastropods rather than filterers. Turning back to the possible hypoxia I mentioned earlier, what could have caused such a hypoxia? While a change to the source water of the upwelling is possible, that is, a change to a deoxygenated state, extensive blooms, their decomposition and resultant hypoxia seems more likely. The 2023-2024 upwelling associated satellite imagery is very helpful and demonstrates a large amount of chlorophyll consistent with unspecified phytoplankton photosynthesis over a prolonged period over a very large area off the Bonny coast and other upwelling centres and extending onto the Lacepede Shelf and into Long Bay. Here's the situation in December 2023, shortly after the upwelling commenced, showing blooming along the Bonny coast with a plume onto the shelf. Late in December, it's marked, and this continues into January, where the blooms are evident on the true colour image on the left. These blooms look almost white. These images make the NASA's Earth Observatory's image of the day on the 15th of January 2024. At this time, marine scientist Kirsten Ruff was in a plane over the area and captured this photo of the massive bloom of Lacepede Shelf, possibly coccolithophore given the white turquoise colour. Also at this time, Todd Dickinson from Boatswain Point off the Bonny coast noted that the state of Long Bay starting in early 2024 was not as expected, and he documented his experiences during the year. Todd is a very experienced sixth-generation fisher. His great-grandmother was a First Nations fisher. He says he knows this area like the back of his hand. His strong point is that the timeline of events has not been understood or acknowledged, but it's crucial. The 2023-24 upwelling was intense and prolonged. This is what he recorded in a personal account of his time on the water in 2024 and into early 2025. He understood the January marine kill at Port Macdonald to be very odd. In January, he noted fish were hiding from dirty southeast ocean currents, not biting, and the water was cold at 11 degrees. The southeasterly winds were howling. The water looked terrible with no bubbles. In February and March, fish were hiding. Weed was everywhere, cold water. Different fish were appearing, never seen before. In February through to June, there is plenty of photosynthetic action going on, underway, extending onto the shelf and into Long Bay, as well as at other upwelling sites. And you can see it here, March on the top panel, and a little later in March on the bottom. April and extending into May, June and July. In July, strong tides were noted, and in August, the upwelling had stopped, and in September, the water started to clear. No squid were to be found, however, but many crabs were seen, and Todd had never noted these before. Water temperatures normalised. Things were quiescent by September. Over the last 3 months of the year, water temperatures increased to 23 degrees. The water was clearer, but catches were poor. Dead, washed-up fish and hypoxic-appearing octopus were noted. Large amounts of foul-smelling dead weed washed up. There's not much to see on the satellite images of October, November, and December 2024, but the direct observations suggest that there were serious problems in these waters. In December 24, January 2025, Boatswain Point beaches were stinking with rotting seaweed. The fish were acting strangely, hard to catch. The temperatures of the waters were warm. In January 2025, there are absent gulwa pippies noted and some decaying mud cockles. Todd noticed skin irritation from contact with the seawater. Poor catches persisted in February and March 25. In March 25, Faith Coleman, a marine ecologist, had a look at some near-shore water near Boatswain Point and couldn't find any live phytoplankton, but remains of dinoflagellates, but not further identifiable. So a summary of a possible interpretation of these observations are an unprecedented, intense, long-duration cold water upwelling leading to very large upwelled, retained and recycled nutrient loads onto Long Bay on Lacepade's shelf, with phytoplankton blooming, subsequent decomposition of these blooms and resultant hypoxia on the shelf and in the bay. Cessation of upwelling, relaxation around mid-year, with a shift in water temperatures to an anomalously warm 23 degrees by late 2024. Later, some marine mortality and ecosystem shifts. Possible coexisting toxic algal bloom later in 2024 with mammal sickness and death. Continuing the timeline, the 2024-2025 upwelling season was delayed and very weak. This is in stark contrast to what had happened in 2023-2024. In fact, it doesn't seem to have really started until early February 2025. I don't have an upwelling index to show, but that would be interesting. Satellite imagery suggests that phytoplankton blooms related to the Bonny upwelling were very sparse during this 2024-25 season. As I said, in very dramatic contrast to what happened in 2023-2024. It's these extreme expressions of variance that are highly concerning. We now arrive at the time when the general public became aware of the harmful algal bloom that would go on to become an ecological catastrophe. Surfers at Waipinga Beach, northwest of Long Bay and off the south coast of the Fleurieu Peninsula, noted extensive brown foam on the water, a marine kill, and they experienced eye and skin irritation and coughing. Nearby kangaroos were noted to be staggering around and ataxic, but later investigations showed that this was attributed to Phalaris grass toxicity, although low levels of sublethal brevetoxins were also detected. The marine kill included South Australia's iconic marine emblem, the leafy sea dragon, shown at bottom right. From here, the spread of the bloom was rapid. It moved westwards towards Kangaroo Island and then up into both those gulfs which I previously mentioned, Gulf St. Vincent and Spencer Gulf, which are in effect inverse estuaries with limited exchange of water with the open ocean and hence sluggish flushing, particularly in summer. The bloom also moved eastwards and entered the Murray River mouth and the northern lagoon of the Ramsar-listed Coorong. Now, I'll just show a chlorophyll anomaly of what happened with the spread of the bloom from the Waipinga Beach. This extends from January 2025 to December 2025. So here's in March, and you can just see the algal bloom starting up and extending into around Kangaroo Island and up into both gulfs, particularly Gulf St. Vincent earlier on, but then later into Spencer Gulf on the western side. Here are a few representative images of the devastation that was caused by this event and which continues. It's taken a toll at many different levels and scales. The Jaranendri elder Michael Maitre has likened the devastation of South Australia's toxic algal bloom to watching Uluru being destroyed. It would be something like Uluru being destroyed right in front of our eyes, and we could do nothing about it. We have a responsibility to look after the things that belong to the South Coast. Now, when they are sick, so are we. This harmful algal bloom is caused by a Karenia mix of 5 species, variably represented across samples, but dominated by the brevetoxin-producing Karenia cristata in 90% of samples. I won't go into the toxicology other than to note that Ian Gibbons has a good site listed at the top of this slide. Brevetoxins can cause respiratory irritation when aerosolized and can also get concentrated in shellfish and cause a neurotoxic shellfish poisoning when ingested. The causes of the marine mortality are varied and include direct brevetoxin toxicity, including that ingested in the food webs, but also hypoxia from bloom decomposition, starvation, and gill inflammation. And here's a video of some aerosolized uh, algal bloom off Metropole in Adelaide Beach in November 2025. So you can see the foam and how it aerosolizes, bringing brevetoxins in that foam onto land. Currently, the bloom has moved into the eastern part of Spencer Gulf, along the west coast of York Peninsula, where it is moving northwards. Is there any validity or value in comparing the Benguela with the southern Australian upwelling systems? At first glance, there are strong similarities, as listed. And perhaps Benguela has already experienced some climate change impacts in advance of here, such as ecosystem shifts, harmful algal blooms, and hypoxia. For example, you can see how these high pressure systems rotating around from a circumpolar view result in upwelling favourable southeasterly winds, both at the southern Australian upwelling system, but also at Benguela, at the tip of southwest South Africa. In terms of retentive upwelling bays, there appear to be strong similarities between St. Helena Bay and Long Bay, for instance. Long Bay has been assessed as being consistent with such a bay in a recent publication, that is, a retentive bay. Hypoxic mortality events are now seen at St. Helena Bay. Hypoxia in the southern Benguela upwelling system is also being evaluated by examining the impact of upwelling and nutrient trapping and recycling. A typical phytoplankton succession cycle is noted in the Benguela, where diatoms initially dominate turbulent upwelling phases, followed by dinoflagellate domination in quiescent periods. The harmful algal blooms there are mainly due to dinoflagellates. From 1980 to 2010, the effects of changing upwelling and wind patterns in the southern Benguela were studied, and a regime shift in the ecosystem was documented, involving both physical and biological components. And the Benguela upwelling system is the only other location where Karenia cristata blooms have occurred. Why are we seeing this particular mix of phytoplankton species in South Australian bloom? The emergence of this bloom and its persistence indicate that Karenia mix is the best at efficiently absorbing useful power for survival and reproduction. Advantages could include a wide range of temperature tolerance. Some are mixotrophic. They can swim up and down the water column, accessing nutrients. Toxins can kill marine life and provide nutrients. They may be able to suppress other organisms. The low silicate in the upwelled water favours dinoflagellates who lack an outer shell, and hypoxia has been found to favour some Karenia species. Other possible contributors, which I mentioned earlier. What were the contributions of the 2022-23 Murray River floods and the marine heat waves in late 2024, early 2025? The Murray River floods were linked to climate change, a positive SAM in 2022, and then repeated La Nina events, which are associated with climate change, with a very large nutrient plume discharge north of Long Bay and an associated non-Karenia harmful algal bloom. The harmful algal bloom was mixed, as I said, non-Karenia. But an important point here is that a nutrient load and bloom on the Lassipede shelf can result in hypoxia, which was documented at the time. Hugo Bassos Oliveri noted that Murray flood plume may have invoked changes within the bottom sediment, resulting in changes to the characteristics and communities of the ecosystems in this location. What was the impact of marine heat wave that was seen in late 2024-2025? Well, the associated thermal stratification may have favoured the Karenia species being dinoflagellates and able to go up and down the water column. In terms of growth, though, the highest Karenia abundances coincided with lower temperature conditions in May and July. I should mention that there was another harmful algal bloom in 2024, which many people don't know about. This involved a cyanobacterium and occurred in the adjacent lower lakes associated with the River Murray. This was new ground, Dr. Cunliffe said, who's the principal Water Advisor for SA Health. This is the largest bloom of this organism we've seen in South Australia, and certainly the largest bloom of this type in the lake. It was pointed out that climate change may be responsible here, with clear winter days and hotter summer temperatures, which are helping the algae to thrive. Professor Saint said we're unwittingly creating these conditions that favour these things. Takeaway messages: how is this Karenia algal bloom in South Australia related to wider and abrupt changes in the Southern Ocean and Antarctica? What's the link? The next section connects the dots, looking at Antarctic sea ice and the Thwaites Glacier. The linkage is largely via the southern annular mode, which is trending positive. As we've seen, this means stronger Southern Ocean westerly winds and more intense upwelling, seen poleward and equatorward of the westerly wind belt. Polewards, we see increased upwelling of warm, saline circumpolar deep water, which interacts with Antarctic sea ice and glaciers at the grounding lines, like Thwaites Glacier. And equatorward, we see stronger upwelling favourable currents. A positive SAM trend also correlates with greater upwelling favourable alongshore wind stress. The Antarctic sea ice decline has been remarkable. The decline commenced around 2016, but in 2023 the decline was sudden, dramatic, and shocked scientists. In 2025, a very important paper was published documenting a marked increase in surface salinity and temperature across the circumpolar Southern Ocean since 2015, coinciding with the start of the sea ice decline. This shift has weakened upper ocean stratification, coinciding with the dramatic decline in Antarctic sea ice coverage. The response from scientists in New Zealand was one of shock and deep concern, as these comments showed. These changes have global implications. They set off alarm bells about how well we can anticipate future climate. This is best explained by the upwelling of warm and salty deep water. We are in uncharted climate territory. What happens in Antarctica has implications for the entire globe. The Southern Ocean is a critical player in our global climate. Although it covers only 17% of the globe, it absorbs more than half of the additional heat and 40% of the excess carbon dioxide that result from human activities. It is imperative that we drastically reduce our reliance on fossil fuels. These results are shocking. This provides more evidence of a major change in the way the Southern Oceans are working, how they respond to changes in the overlying westerly winds. The research all suggests that climate change is really starting to be expressed through the Southern Oceans. The implications are very worrying. And a recent preprint release states there is good reason to believe that the positive SAM trend under greenhouse gas forcing will drive more warm saline circumpolar deep water upwelling into the upper ocean, where it will reinforce the current low sea ice state. The Thwaites Doomsday Glacier, as it's known as, is the most consequential on the planet. It's melting fast and is a keystone glacier holding back the West Antarctic ice sheet. It also has a vulnerable siting. If Thwaites melts or collapses, it adds 65 centimetres of sea level rise, and a complete associated Western Antarctic ice sheet melt equates to 3 meters of sea level rise. Again, there's a link with the positive SAM trend. The stronger westerly winds move polewards, and warm circumpolar deep water upwelling and transport into the cavity below Thwaites is favoured. In January 2026, hot water drilling was performed at the level of the Thwaites in order to assess the ocean water in this location. On the 30th of January, the ocean was accessed at a depth of 900 metres. The summary of the drilling results is shocking. The thermal driving force is 3.1 degrees Celsius, and the water at the grounding line is turbulent due to subglacial water discharge, which is very buoyant. This dramatically increases energy transfer and melting. These figures are fixed, they're not negotiable, and procrastination is not an option. This dire and urgent situation led to awareness campaigns and briefings in the latter half of 2025. The leader of the Australian Antarctic Program Partnership noted, "It is vital to keep Antarctica and the Southern Ocean in the forefront when making decisions about climate policy. Often regarded as the bottom of the world, our research demonstrates that Antarctica and the Southern Ocean are in fact central to the Earth's climate system, while at the same time acutely vulnerable to global heating." There was absolutely no wriggle room in this commentary. Nerily Abrams noted, "The stakes could not be higher. Things are happening much faster than scientists anticipated.
Neil,
We
could I ask
must..."
you to start wrapping up in the next few minutes because we have only 15 minutes left for Q&A.
Okay. We must have urgent system-wide transformation. Drastic greenhouse gas emission reductions are needed. So what's the wide boundary, big picture perspective? What's the bottom line? We have to partner with Gaia, if Gaia is willing, to rebuild and promote Holocene basin stability in a simple pro-social bioregional context. I won't go into this, but I'll leave these slides. You can have a look at these. I'll just quickly go through the last 4 points. We need immediate drastic reduction in fossil fuel use. Too much of a good thing is pervasive. The inverted U curve, often driven rightwards by the maximum power principle, which includes energy flow. And this is a very important final point. First Nations, Indigenous knowledge, wisdom, and governance. Finally, and very importantly, First Nations knowledge, wisdom, and governance must be a cornerstone at the centre of the path forwards from here. The devastation that this algal bloom has caused First Nations people is difficult to understand. But perhaps Narrandjera's elders Mark Kumatri's lightning to watching Uluru being destroyed gives us some idea. To paraphrase his words, when nature is sick, so are we. We have responsibility to nature. And the last slide, the Narungga people, the traditional owners of Garanda or York Peninsula, have been greatly impacted by this algal bloom. In a submission to the Algal Bloom Inquiry, they wrote about the enduring and ancient connection to sea country and the importance of the butterfish or dusky moorwong fish to their identity among other Aboriginal nations. This fish and the gulfs are part of their dreaming stories, but both have been greatly harmed. The Narungga people note their vulnerability to climate change, yet they have not contributed to it. Surely many lessons here. Thank you for your attention.
Thank you, Neil. That was an excellent talk. It was really very different from anything else we've ever heard, and it was a very excellent overview. As the moderator, I'll start with the first questions. How much of this is related to acidification of the ocean, which is the last planetary boundary which we crossed? And you haven't mentioned how much acidification of the ocean has contributed to the algal bloom. I just wanted to know that. And the second question I had is, how much has Australia converted to renewable energy?
In terms of the acidification, yes, I've sort of come across it. It is a big issue. I have not seen it really mentioned too much. I'm just trying to think. Yeah, I have not really mentioned when looking at for example, the eastern boundary upwelling systems. I don't recall seeing too much about acidification. It's mainly about the harmful algal blooms. I'm not sure how they're related to acidification and hypoxia. Um, so perhaps other people know a bit more about acidification. Uh,
Hmm.
in terms of renewable energy in Australia, uh, in South Australia, where I am, quite a lot of electricity is produced through, well, I call it rebuildable energy. Yeah, so it can be up to 70. It depends, but it's mainly wind with some solar, and it can vary. But in terms of the electricity, which I think is around 30% perhaps of total energy, um, the electricity supplied by the rebuildables uh, can be around 70 or 80%. Um, so South Australia is significantly higher. Um, I think with the exception of Tasmania, uh, but in terms of renewable or rebuildable energy going on across Australia, um, there's yeah there's concerns about the rollout of all the rebuildables and how
Hmm.
how it's all going to fit actually. So uh, I think the transition is to a low energy bioregional context.
Right. Okay. So, and now we have Anitra who's on deck. Actually, Anitra, you're the next question. And then after that comes Charles.
Yes, thank you, Neil, for excellent talk. And it's very shocking and alarming. I'm just wondering because I know that there are very strong dust coming, which is very contaminated from both China and India subcontinents from their fossil fuel burning of coal. And the two of them have most of the coal which is being burnt. And it's settling into the bays throughout Southeast Asia and along the Australian coast. So I'm just wondering if you have integrated at this point the the effect of the dust which comes down and also stimulates
Hmm.
the algae with the ocean current.
I have not seen anything about that. The only thing I've heard about dust and phytoplankton is, I think, via iron. But I've not really read anything that's evidence based uh, around that sort of dust aspect at all, actually. Yeah.
Thank you.
So Charles Hall, you're up. And then after that comes Claude Butner.
Uh, I can't get can you hear me? I can't get my
Yeah, we can hear
camera.
you. That's okay.
Yeah, I was going to ask you about iron, and you just said something about iron, but back in graduate school, I studied this stuff a bit. There's a paper by Slobodkin you might see, but there's you have a lot of marvelous stuff, but you don't. Somebody asked back a little bit. Ted Manning asked a good question, and I don't quite get a connection as to why these particular conditions generate the dinoflagellate bloom. Um, they certainly would develop a bloom. I mean, it's a bigger problem maybe that we don't know in the world. But and you talk about uh, something about oxygen, but I didn't. To kill things, you have to go down pretty close to zero oxygen. And you didn't show any oxygen measures. Did the oxygen go that low? That's very, very rare in reef conditions.
Yeah, I think so the only oxygen data that was obtained was at the time of the River Murray floods. Um, there was some oxygen. There was some oxygen measurements done at the time of the 8 Mile Creek uh, mortality incident, but it's difficult to actually understand uh, where they were done and at what depth. Uh, my understanding is that if you get below around, uh, I think it's around 4, there's distress. Um, and if you get below, say, 2 to 3, it's sort of mortality.
It's
That's
about
my
right. Parts
yeah,
per million, yeah.
yeah. So, but you're right, Charles. I think that's a good point. I think that monitoring of hypoxia is really important, um, and particularly in those bays, those retentive bays. Um, and that's been going on the Benguela. There's a lot of research been going on there. And obviously, where you are up in Oregon, there's been a lot of research around hypoxia off the shelf there.
Much more
So,
in Louisiana.
no, the Northwest, Pacific Northwest, there's a lot of hypoxic.
Yeah, but even more in Louisiana. But
Yeah.
that's okay. Doesn't matter. Well, I'm just wondering what's killing the fish. I'm not sure. You see, the phytoplankton, especially in the summer where you have long days, are producing oxygen, and they only use oxygen if they die and go down to the bottom and decompose. But these things have been happening for millennia. Otherwise, we wouldn't have any oil off of Louisiana. Oil has to be formed in anaerobic conditions. So it's it's common enough in Earth history to have anoxic coastal waters, and I'm wondering whether you've just been lucky in not seeing it for the last 50 years or 100 years, or uh, whether or not this is a recurring phenomena, or is it new? How much agriculture is there in the Murray watershed?
Hmm.
Well, in terms of looking at sort of the non-Murray aspects, say the upwelling aspects, I think there's two aspects there. The hypoxia is increasing in the upwelled water, so that's a global phenomenon. So hypoxia has been increasing in upwelled water. For example, off the Oregon coast there, they've noticed that it's becoming more hypoxic. But most of the hypoxia there, I think, is caused by uh, the increasing blooms. So there's more nutrient loads. It's being recycled on the shelf, and the blooms are the larger blooms are decomposing and therefore driving more hypoxia than it used to be. So climate change, I think, is driving hypoxia there through two mechanisms. One is the upwelled water is more has less oxygen, and also the blooms that form are more extensive in these times of increased upwelling, and then that causes more decomposition and more hypoxia. So I think there's two mechanisms there. In terms of the Murray River, obviously that showed that all that nutrient load that came out, the sediments that came out, were able to drive a, a, a harmful algal bloom in that area. It wasn't Karenia, but that was enough to create quite hypoxic conditions, actually, just by the ocean near the Murray mouth.
Okay. Clyde.
I mean, I think you're really onto something, but there's a couple of things that need to be examined. I can't believe there isn't somebody from Australia out there measuring oxygen. And
Uh, um,
nutrient ratios, the ratio of silicon to other elements is
I
can
think No,
can be very important in all kinds of things to do with Redfield ratios. So if you want to, we can meet on that. But I mean, I don't have better information than you. What you did was amazing. Very impressive what you put together. It's just a little more I want to see.
Thanks, Charles.
Good, excellent. Thanks, Charles. So, Claude, you're on.
Yes, a fascinating presentation that I will be sharing widely in my small social circles. Some of the people would like this information. I put a comment in there because I had a session with ChatGTP. I was interested in maybe I'm a doomster forward looking to food insecurity issues, which seems to be kicked down the road for the future concern. But ChatGTP mentioned that there's actually been some experiments with bringing artificial upwelling for the kelp industry. And I'll just call that to your attention that there's a question that you can save a little session with ChatGTP on this. And so the question is this a good development? I can see that the interest that is morphing from food to sequestration might mean that we will be essentially taking food and instead of harvesting it, we'll be putting it in the deep ocean, which seems immoral at a time when people are going to be facing on a pretty large scale food insecurity on the planet.
I think the answer is bioregional, low energy living and growing our own food, Claude. I think that it's all going to be, as Nate Hagen says, the great simplification. I don't see any role for artificial upwelling, I'm afraid.
So even though I agree with you, look for big ag to morph into strange ways as things get worse. So I will leave it at that. Time is short. We can go on to the next question. Thank you so much. This is fascinating.
The next one is Ted. Thanks, Charles. Claude, sorry. And Ted, you're up next. Okay. And then I will ask a question on behalf of Laura Laney.
Try and find out whether I got my video. If you let me put it on, I can find out if I have video. No.
Don't worry about it. Just have to answer the question.
Neil, that was fabulous. I actually lived in New Zealand and Australia for a while, and I understand where you're coming from. I have a friend who did a lot of work on Kangaroo Island, mainly from a coastal management and eco-tourism perspective. But my concern is you have a wonderful amount. The real issue is, can we in fact integrate it? Can we in fact obtain other data regarding the sensitivity of key species, or where I come from, the sensitivity of tourists, the sensitivity of people to what the conditions are of the coast and of the oceans? So I'm more or less challenging you and others to go further and try and integrate these variables, these indicators of change. To extrapolate what could happen to other ecosystems. So I'll ask if you can respond to it. I know it's a tough one. It's everything at once. To the point of view of where it means something to another customer, but I'd like to throw it out anyway.
Look, I think that, as I said, I think it's going to be a much simpler bioregional life, but I think ecosystem restoration is going to be a really, really important thing, along with pro-sociality and food growing. I don't know what that's all going to look like in the bottleneck. But ecosystem restoration at the local level, we're really going to have to focus on that. I don't really know what's going to get through the bottleneck in terms of more larger sort of surveillance. But I agree that I think knowing what's going on out in the world and monitoring is going to be really, really important as we try to bring things back down into the Holocene attractor basin. So I think the way I see it is that everyone will need to work hard to pull pull that marble back down into the basin and to deepen the basin. I think we all need to work hard in our local communities doing that, also appreciating the wider global picture if we can somehow get idea of how we're all doing in relation to that basin.
Well, that's very, very appropriate. By the way, we have Anita Throwhog here. She didn't get a chance to respond to this one. We've just got back from Sri Lanka, where our job has been to try and do coastal restoration in the mainly for carbon reduction and so forth. If she wanted to say something, I'd try and give her 30 seconds now, because she knows more about restoration challenges of anywhere in South Asia and the Caribbean than anybody else. If hopefully she hasn't gone, because she is very knowledgeable about this. If not, we can go to someone else and respond.
I think
I guess she may have gone.
Yeah. Laura Blaney wanted to ask a question in terms of response to the HAB and fish skills, human, etc. Were any lessons to be learned from other EBUS
You want to give her a minute?
Where HABs were more common?
Yeah.
That was her question.
Anita?
So in terms of response to Southern Australian HAB and in fish kills,
Yeah.
human health, etc., were any lessons able to be learned from any other EBUS where HABs were more common?
Well, looking at, for example, Benguela, they're obviously monitoring things pretty carefully. I think they've been through a regime shift before what's happening here, actually. This, in the same way that Western Australia has gone through a drying trend earlier than what we have. So I think these things are happening, have happened unequally around that sort of southern belt, if you like, in the Mediterranean belt there. In terms of learnings from the Benguela, you know, they seem to have been onto this issue about, you know, retention of nutrients and the recycling of nutrients on the shelf. And they've done a lot of work around that. And they've noticed that the upwelling intensity has been increasing and the winds have been changing. So they've documented all that. I think the bottom line, as I said, the bottom line is an immediate and drastic reduction in fossil fuel use. It's really the only way that, well, everything else is really, you know, tinkering around the margins. We really have to just get, you know, we really have to get fossil fuel use dramatically down quickly.
No kidding. I published an article on that today. I'll send it to you. But on another note, so I actually at this point, I know there are other questionnaires, but for the recorded session, we'll come to an end. So I'll get Ted to thank you, and then we can go into the informal unrecorded session. So Ted?
Yeah, just one moment. I got to find my...
But excellent job. Excellent job,
Yes,
Neil.
that was
Very
super. You do what we like at the Club of Rome, which is begin to integrate a great deal of different disciplines to focus on something that can be important to all of us. And you have generated a very good discussion on that basis, as we usually try to do. I lived for a while in New Zealand. I did my doctorate there, but I was mainly doing land and water interfaces, not water. So it's very nice to hear somebody focusing on what the ocean really means to us and how it can, in fact, affect everything. So thank you again. So I would thank you for coming all the way from Australia and jockeying your time of presentation so it can actually fit the other half of the planet. It's something always a challenge for us. So we would ask everyone who is watching this to join with us. That's what keeps us alive. And we're now in our 280 something presentation. And we'll be on again next week on another topic dealing with human biosphere relationships. So thank you all again for coming. Thank you again, Neil, for making it interesting.